In this lecture, we try to find the area of a surface of revolution. Surface of revolution. So that means so you have a you generate a surface by rotating about a axis. So generate a surface. Generate a surface by rotating a curve about an axis. So in this case we can talk about two cases, the x-axis and y-axis. So let's try to kind of develop the theory and see what are the related ideas behind. So let's talk about the easiest case. So let's say you have a line which is parallel to the x-axis, and then what we can do, we can rotate about the x-axis. So once you do that, you can see it's going to create a surface of a cylinder. So that's what's going to happen if you rotate this part of the curve. So and then it's going to create a cylinder. So if you're going to call this height is L, and then the radius of the cylinder is Y, so then we can easily find the surface area. So it's like, so we try to find this area. So that's the surface. So you try to find this surface area of this, but we know that the perimeter of this one is 2 pi y. So then the surface area is simply going to be 2 pi y and then multiply by the height. So 2 pi y is the perimeter and then multiply by the height. So that's going to give the surface area. So it is the perimeter times the height. Now what we have is a kind of because what we try to do is, those are not like parallel lines to the x-axis in general. So what we have is a kind of curve, and then what you're gonna get a curve, and then you're gonna rotate it about x-axis. So in that case, we cannot use this as setting for in a general situation. So what we want to study is, we need to study this situation. So what we're gonna get is let's say you have like a slant line like that, and then you're going to rotate that about the x-axis. So if you rotate a slant line, what's going to happen, so it's like a mirror image. So it's going to jump here and there. So you're going to get go like that, and this one go around like that. So it's going to create a surface like this. So this is what you get. So this kind of surfaces have a special name. So these surfaces are called frustum. So it's called frustum. Okay, frustum. So the goal is to find the area of this surface area of this one. So we have here y1, that is the smaller radius, and then we have a larger radius, that is, I'm going to call y2. And then if we have y1, y2, then you can also find the average radius. So what's the average radius means? So you can find the average. I'm going to call it y star. So it is the y1 plus y2 divided by 2. So that is the average radius. Radius. So average radius. So we can mark the average. So it should be in between the two. So that's the average radius. So I'm going to call that average radius y star. So and then there is a really nice result from geometry, that you can show that using the surface area of a cone. So if you use a surface area of a cone, you can show that the surface area of the frustum, surface area of the frustum is given by 2 pi the average radius times the slant L. So it's not the height in this situation, that's a slant L. So the slant L is not exactly equal to the height. So height is smaller than that because of the Pythagorean theorem, because this is like slant. So but this result you can show using the area of a cone. So so we can show this. We can show this. So this using the surface area of a cone, surface area of a cone, and this one we know that is pi r L. So that is the pi r L. L is a slant L. So r is the radius, base radius. So that's pi r L. So we can use that result to show that the surface area of a frustum is 2 pi 2 pi average radius times L. 2 pi average radius times L. So now what we're gonna do, so we can use this idea to find the surface area of a general curve, surface area of a surface of revolution. So let's look at the general situation. So let's say you have a curve like this. So this is a curve, and then what we can do, as before, we can rotate about the x-axis. So if you rotate about the x-axis, what's gonna happen is so it's gonna get the mirror image first. So it's gonna go like this, like that. So that means it's gonna go like that, and this one gonna go like this, and that is the A value, starting value, and that is the B value, the ending value. So so what's gonna happen is we can kind of draw a general situation. So what we're gonna do, we're gonna pick the y value, and then we slightly move from that. So we're gonna go I'm sorry, not the y value, the x value. So we're gonna go with the x value, and then what we can do, we're gonna slightly move away delta x or dx. So we're gonna move away dx, or you can say delta x dx. So it's a limiting situation. So now what's gonna happen, we're gonna consider the two radii in this situation. So we have one like that, the another one like this, and then what's gonna happen, it's gonna generate a surface, small strip like this. So that's gonna happen. So we have that, and we have this. So that is the surface area generated by these two. So what's gonna happen, you can see that these two have two radii. So I'm gonna mark them y1 and y2. So what's gonna happen when y1 and y2 are very close to each other, and you can see that it can be close to the general y in between those two. So we have a y, so this is you can say y1, this is y2, and you can pick any y in between like that. Okay, so that's the y is you can say corresponding to x. So you can have y and then y plus delta y, like that. But this is the, so we have the y1 sitting here, that's the first radius, the second radius, and y is the middle average radius. So you can see that if they are close to each other, then you can say it's close to y. So then what's going to happen in this situation, so the area of the frustum now becomes, so so you can see this is like a curved situation, but you can see that you can approximate the curved surface by the surface area of the part of the frustum. So that's the situation what we can do. So we have a curved area, but this area you can approximate by the area of the frustum. So that means so you can have so the surface area of the element means this small part, so this part what we normally call the element, small part of the element, is what you can do. You can use the same formula. So it is 2 pi, so we have the average radius, in this case y1 plus y2 over 2, and then the slant L, the length. So this length we can find as we find earlier, so that's the L of this one, so times L. But you can see that this simplifies very well, so you can write this one as 2 pi, but y1 y2 are very close to y, so you can write this one as 2y over 2L. So what's going to happen, you're going to get 2 pi yl. So that means you just need the general radius in this situation. That means the surface area formula now going to be, so the surface area is equals to you can say 2 pi, so 2 pi a to b y, and then the slant L, as we found in the previous section, it is dy over dx squared square root dx. So what's going to happen, the new thing is here the y term. So the y term is the new one added here, and then the 2 pi y is the new one we added here. Otherwise it's just a similar thing from the previous one. Okay, so that's the formula. So so the new one added 2 pi y, and the other things as before. Okay, so so let's look at maybe 2 examples and how to kind of simplify problems here. So I'm going to do 2 problems, one rotated about the x-axis and then one rotated about the y-axis. So so the first example, so let's say the curve y equal 4 minus x squared from -1 to 1. The curve actually this is an arc, of the circle, arc of the circle, x squared plus y squared equal 4. So find the area of the surface finds it by rotating this curve, about the, let's say, x-axis. Okay, so you have a curve So let's try to draw corresponding figures here. So we're gonna have a curve. So it's a part of a circle, but it's going from -1 to 1. So this is a part of a circle. So you're gonna see like that. So that's the curve. Now what we're gonna do? So it's gonna go from -1 to 1. That's a part of a circle, and then we can rotate this around the x-axis. On the x-axis. So what's gonna happen? It's gonna go like that. It's gonna go like that. So that is the surface you're gonna get. So you're gonna get a surface like that. So what you want to find? We want to find the area of this circle, this surface. So I'm gonna mark that surface. So it's gonna be like this. So that's the surface that we have. Yeah. So that is the surface. Okay. So that's the surface. So we have the surface generated by this. Good. Now what we're going to do, we're going to find the area of this surface. So what we need is, so we need a few things here, and we know this curve is y equal 4 minus x squared square root. So that is 2, that is -2, and then the values are going from -1 to 1 along the x-axis. So we're going to use a formula. So what we need to do is we have y equal 4 minus x squared. According to the formula, we first need the derivative, so we need the y prime. So we can use the chain rule to do that. So we have 1/2 4 minus x squared to the -1/2 times the derivative of the inside function, -2x. And if you simplify this one, you're gonna get a negative x over but 2 get cancelled, negative x over 4 minus x squared square root. And then the next thing is we do 1 plus dy over dx whole thing squared. So it is 1 plus, we can square this, so it is so you're gonna get so you're gonna get x squared over 4 minus x squared. That's what you get when you squared. And then you can simplify this one, take the common denominator. So that means you're gonna get 4 minus x squared plus x squared over 4 minus x squared. You can see in the top these two get cancelled, so you simply get 4 over 4 minus x squared. So it simplifies very well. Now what we can do, we can use the surface formula. So the surface area is, we have 2 pi a to b y 1 plus dy over dx squared square root. And in the exam you're going to get points for writing this one, so make sure that you remember this. Now let's plug in here. So we have 2 pi, starting value is going from -1 to 1. Y, what is y? Y is 4 minus x squared square root, and then 1 plus, so we'll take the square root of that. So it is what do you get? You get 4 over 4 minus x squared square root dx. And then I'm gonna write extra simplification step here. This one is not really not necessary, but for clarification I'm gonna write that step. So we have 4 minus x squared square root. Then you can split the square root, so it's going to be 2 over 4 minus x squared square root dx. And you can see that this term and that term get cancelled. So you simply get, so we were lucky. So you're going to get 4 pi -1 to 1 dx. so that is 4 pi. You're gonna get x 1 to -1, that means 2, so that means you're gonna get 8 pi. This is an area, so it is a unit squared. So that is the surface area of the solid of revolution. So here the problem is we rotate about the x-axis. So let's try to do a problem where we're going to rotate about the y-axis. So what's going to happen when you rotate about the y-axis? You have to change the equation as well. So let's do something like that. So let's do so let's say rotate about y-axis. So what's gonna happen here? So you have a curve, and then we're gonna rotate about the y-axis. So what's gonna happen? So it's gonna generate a surface like that. So your curve, now you can write as x equal a function of y, and then you're gonna have y limits. So y limits we normally write c and d, just to avoid the confusion. So that means your formula gonna be so the surface area. So the formula is, it is now c to d 2 pi x, now 2 pi x 1 plus, it is not dy over dx, is dx over dy. So dx over dy squared, and you can see that the small strip go up, so it's a dy. So it's a dy. So that is the formula if you rotate about the y-axis. So let's do a problem to understand this method. So let's do, so we can say the arc of the parabola, x equal square root y. Here we can say y going from 1 to 4 is rotated about the y-axis. Find the area of the surface generated. Okay, so always, like, these kind of situations, it's a good idea to draw a kind of supporting curve here. So what we have is very similar to what we drew just a few minutes ago. So it's going from 1 to 4. So the square root. So you can see that's a square root curve on the other direction. So you can see it's a square root curve. Now what we can do, we can rotate this curve about the y-axis. So that means it's going to jump to this side. So that is the surface generated. Okay. So this curve is x equal square root y. So we have everything we need. It's going to go from 1 to 4 actually. So it is starting with 1 and go to 4. Okay. So so the first thing that we can do is we can find the derivative. So we have x equal square root y. So then the dx over dy is 1/2 y to the -1/2. In other words, 2 square root y. And then what we normally do is we do 1 plus dx over dy whole thing squared. So it is 1 plus, you square this, so it is 4y. What we normally do is we're going to simplify this. So take the common denominator. If you take the common denominator, this can be 4y plus 1 over 4y. Okay, now we can use the formula. So let's use the formula. So the surface area equals 2 pi the y value is going from 1 to 4, 1 to 4, so it's going to be x 1 plus dx over dy square root dy. Okay, so let's plug in. So the 2 pi, so it is 1 4, x is square root y, and then here we have 4y plus 1 over 4y square root dy. So you can see that everything is in terms of y, so you can integrate, but we can do as before some simplification here. So we have 2 pi and then 1 to 4 square root y, then we can do this one as 4y plus 1 square root over 2 square root y dy, and you can see that square root y cancels square root y, and then 2 cancel with 2, so you're gonna get pi 1 to 4 4y plus 1 square root. This is a very easy integral using the substitution method or the 4 formulas, so I'm going to go with the 4 formula. So a derivative of the inside function is 4, so that means you can multiply and divide, so 4 and then 4y plus 1 square root dy. So this is a very easy integral. So the integral is going to be pi over 4, the power is 1/2, so add 1, so it becomes 2/3 4y plus 1 3/2. The values are 4 and 1. So let's plug in the values. So if you plug in the values, there are simplification here, so you're going to get pi over 6 first, and then we're going to put 4. So if you put 4, this is going to 17, so it is 17 3/2 minus, if you put 1, it's going to be 5, so 5 3/2. You can leave it like that, or you can write the 3/2 as in this form, so pi over 6. So you can write this one as 17 square root 17 minus 5 square root 5, and then unit squared. So this is a problem along the rotate about the y direction, and the previous one is rotate about the x direction. So you can do more problems in the homework to understand, you know, some other application, some other simplifications. So that's the end of surface area problems.